Alright, so given that the foci of a hyperbola are at 0, 5 and 0, negative 5, and the vertices are at 0, 2 and 0, negative 2, we want to find the standard form of the hyperbola. Okay, now, we don't necessarily need to sketch this guy out, right, but it may help, okay? So let's just do a rough little sketch here. Okay. So where are the foci? Right, the foci are going to be at 0, 5, which is on the y-axis, and 0, negative 5. Okay. Foci are usually denoted using red. Okay. And where are the vertices? Right, the vertices are going to be at 0, 2 and 0, negative 2. Right, so we can imagine, we don't have all the information that we need, right? But we can imagine that these hyperbola are going to open up and down. So what we can determine just from this is which equation we're going to use. Okay, now because this opens up and down, we know that the y squared term should be first. Okay, so y squared divided by a squared minus x squared over b squared is equal to 1. And once again, we know this because this hyperbola open up and down. Okay, so what are a, what are b, and what are c? Well, C's hopefully should be pretty straightforward, right? C is the distance from the center to each foci. So in this case, C is equal to 5. And what about A? Well, A is the distance from the center to each vertex. So we know that A is going to equal 2 in this case. Okay. So now to find B, we use this relationship, right? C squared is equal to A squared plus B squared. Okay, so 25 is going to equal 4 plus b squared. So that tells us then that b squared is equal to 21. Okay. Now b is obviously going to be the square root of 21, but in terms of finding the equation, we don't really need that, right? So we should be able to just give the equation of this hyperbola using a squared and b squared, right? So what's our final answer? It's going to be y squared over 4 minus x squared over 21 is equal to 1. Right, and that is going to be the equation of this hyperbola with these particular characteristics.